All right, now let's take a look at the inverse of exponential functions, which are logarithmic functions. And a logarithmic functions will have opposite characteristics of exponential functions. Okay, so we're going to look at characteristics of logarithmic functions of the form f of x is equal to log base b of x, where the domain of f of x is equal to log base b of x consists of all real numbers 0 to positive infinity, and the range consists of all real numbers from negative infinity to positive infinity. Now remember when we talked about the characteristics of logarithmic functions, what that entails, okay, what it entailed, and it's going to be the opposite of everything that was taught before. Now, this time the graphs of all logarithmic functions of the form f of x equals to log base b of x passes through the point 1, 0, whereas with exponential functions it passes through 0, 1. Okay, because f of 1 equals to log base b of 1, which gives us 0. And a logarithmic function has an x-intercept, okay, which is 1 comma 0, but there will never be a y-intercept. If your b, meaning that base of the logarithmic function, is greater than 1, then you have a graph that goes up to the right and is increasing function. If your base is between 0 and 1, let's say 1/2, 3/4, then you have a graph that goes down to the right and is a decreasing function. Whereas the exponential function has a horizontal asymptote, the logarithmic functions, you have a vertical asymptote. It says here it approaches but does not touch the y-axis. The y-axis, or we can say x equals to 0, is called the vertical asymptote. So here's an example of a logarithmic function with base 10. Okay, and we're going to be looking at how to convert from exponential to logarithm in a couple of videos, but I want you to notice that your y-axis is your vertical asymptote, which is x equals to 0. It has an x-intercept at 1, 0. Okay, as you read this from left to right, okay, the range is the range is from negative infinity to positive infinity. Excuse me, as you read it from left to right, the domain is going to be from 0 to positive infinity, but the range is going to be from negative infinity to positive infinity. Remember the range, we're looking at all of the y coordinates. Okay, so this is the type of graph that we will be looking at. Now, I'm definitely not going to camp out in this section of graphing, but we've done enough graphing at this moment in the course. Now, transformation of logarithmic functions. Let's just quickly go over this. So we have here f of x is equal to a times log base b of x minus c. I do have the two negatives there. Let's talk about that quickly. What doesn't change is your vertical shift. If it's positive, it moves up. And when it's negative, it moves downward that number of units. Inside the parenthesis, there's a horizontal shift. If the c is when the c is positive or that number is positive, you move to the right, and when it's negative, we're going to move to the left. So this is a little bit different. Whereas before, um, if it was positive, we would go in the opposite direction. So notice what happens here. If there's a number in front of the log, that means it's going to be a vertical stretch or shrink. Okay, if that number is greater than 1, it's going to be a vertical stretch. If it's between 0 and 1, it's going to be a vertical shrink. Now, in front of the A, if there's a negative, then it reflects about the x-axis. Now, inside the parenthesis, if or this x is negative inside the parenthesis is going to reflect about the y-axis. Your base B will never ever be negative as we look at logarithms. Your base needs to be positive. Okay, so if we ever have that, you cannot graph it. We can't do anything to that. Okay, so that's the information on um, logarithmic functions.